Alright, the first topic, system and the center of mass. First, what is a system? System is a group of objects you choose to study, or in an easier way, the collection of objects. It can be a single object or several objects. Usually, the system will be clarified in the question, so you don't need to really worry about it in this unit, but we'll talk about it later. Next, the center of mass. Center of mass, or COM in an easier way. The center of mass is a point where the whole system's mass could be considered to act. In AP Physics 1, we'll only discuss how to find the center of mass of one or more objects with equal mass distribution. So let me give you an example. This is a basketball. This is a situation for one object. This is a basketball, and the mass is equally distributed. The center of mass is just in the middle. And you may ask, how do we figure out the center of mass for several objects? Well, nice question. Let me give you another example. This is a rock with mass of 5 kilograms, and this rock, another rock, has a mass of 3 kilograms, and the distance between them is 2 meters. 2 meters, yes. And then it's asking you where the center of, find out the center of mass. Center of mass. So what we need to do is draw the number axis first, and then assume the position of the rock with the mass 5 kilograms is 0. Then the position for the rock with a mass of 3 kilograms is 2, because this is positive 2 and it is going right, which means this is positive 2. And then plug in this equation. X center of mass is equals to, oh my god, is equals to, oh, this is awful, m1 times x1 plus m2 times x2 plus blah 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 plus mn times xn over m1 plus m2 plus blah 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 plus mn. M is a mass, and x is the distance to the point you pick. For example, for this one, I would usually pick this point, which is 0. So 0 is my starting position. So let's plug in the equation. So what is the position for the center of mass? XCM is equal to m. What is the mass for the first rock? It's 5 kilograms times the distance to the point you pick. What is the distance from 0 to the point I pick, which is also 0? It is 0, right? So let's put 0 there. Plus, what is the mass for the second rock? It is 3 kilograms times, write down 3, times what is the distance from 2 to the point you pick, which is 0? It's 2, right? That's right, 2. Over m1 plus m2. What is the mass for the first rock? It is 5. What is the mass for the second rock? It is 3. So after simplify it, we will get 0.75 meters, which means the center of mass is around here. This is 0.75. Now let's talk about how do you find the center of mass in two-dimensional world. So it's very similar. We know in two-dimensional world is like it has an x-axis and y-axis. Right up here, I already gave you a formula, right? It's basically for the x-axis. So for y-axis, it's basically the same stuff. Y is the center of mass is equal to m1 times y1 plus m2 times y2 plus blah 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 plus mn times xn over m1 plus m2 plus blah 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 plus mn. Oh, this one's supposed to be ym, my bad. And m is still the mass. Y is the distance to the point you pick vertically. This one is horizontally. Horizontally. So let me give you another easy example, but I will not do this problem for you. This is another rock. Yeah, another rock with a mass of 8 kilograms. 8 kilograms. This is, yeah, another rock. Well, actually, this is a stone. Yeah, a stone with a mass of like 3 kilograms. At position 4, 4. So let's just plug in a formula. For x, we'll just write what is the mass for the first object. It is 8 kilograms. Times, usually I will pick the point of one of the objects, like this. I'll pick the points of the stone, the rock, at the position which has a mass 8 kilograms. It is at the origin, which is 0, 0. What is the distance from 0 to 0 horizontally, which is 0, right? Well, actually, I'll change this number to 3 for 3. 8 times 0. Plus, what's the mass for the second rock? It is 3, right? Times the distance horizontally from 4, 3 to 0, 0. This is the distance horizontally from this stone to the origin, which is 4. 3 times 4. Over the sum of mass, which is 11. 8 plus 3, right? Which we will get 12 over 11. I will not do the math. And for y, basically the same thing. What the mass for the first rock is 8 times from this position to the origin. Yeah, it's still 0, right? Plus the mass for the second, for the stone, which is 3 times. Now this is a little bit different. The position vertically from this stone to the origin or to another rock is this. It's this distance, this part, which is 3. So let's write 3 times 3 here. And then over the sum of mass, which is 8 plus 3, is 11. And then you got 9 over 11. So the center of mass is at the position of 12 over 11 and 9, 11. This is a coordinate, which is around here. Yeah, that's easy, right?